As we said, we have this replicating portfolio, which consists of the finite number of stock holdings here, and you have this psi, which goes to the risk-free account and grows proportional to the risk-free rate in this delta t time, regardless of the state of the nature. So you can solve these two equations for these two unknowns, and this is what you will get. So this phi, actually, this is gonna be called as the delta hedging formula, because actually what we are doing is we are replicating the value process of the financial derivative using this replicating portfolio. And you can see that by the no arbitrage arguments, if the value at time 1 for the financial derivative is equivalent to the replicating portfolio, then time 0 values must also be the same. Otherwise, there exists an arbitrage opportunity, and everybody can buy the cheaper one at time 0, and the price should go up to correct this arbitrage opportunity. So you can write down the value of the financial derivative V at time 0. So this is finite number of stocks times S0 value. S0 is here, and then this is the money in your risk-free account, and you can see that this is the basically discounting factor is also showing up here. So whatever remains from your investment to the stock, then actually you are putting the rest into the risk-free account. So this actually gives us a pricing mechanism for the financial derivative at time 0. So we can rewrite this V, we can just rearrange this a little bit to get this expression. You can try this, you can work out just a few details here. And basically we will notice that once we rearrange this expression, it looks like an expectation operator now. Because notice that we have a quantity here between 0 and 1, and another quantity between 0 and 1. Actually, when we add these two terms together, we get 1, right? That if you add these together, so these, when you add them together, the result equals to 1. And we can also notice that each of these terms are actually between 0 and 1, again from the no arbitrage arguments, because this is the stock price when the stock goes down. So it's going to be always less than this risk-free growth. Again, if this is not true, I mean, if this is not greater than S1 tail, then there exists an arbitrage. And similarly, when the stock price goes up, this state of the nature should be always greater than the risk-free growth of the initial S0 value. Otherwise, again, there exists an arbitrage opportunity. So we can see that we have two quantities here, just like weights, and they add up to 1. Okay, so we can give a artificial interpretation to these quantities as probabilities, actually, because they satisfy the property of being a probability. And we will call this as the risk neutral probability measure, and we will denote this quantity as P tilde, and Q tilde is going to be just 1 minus of P tilde. And as we said, if you add these together, we get the sum equal to 1. So if we rewrite the whole thing again, the financial derivatives value at time 0 can be written actually as an expectation now with respect to this risk neutral probabilities, and we will use this E tilde notation to represent that this is a risk neutral expectation. Okay, so that means we know how to calculate or how to compute the risk neutral value of this financial derivative at time 0. And you can consider an example here. So in this binomial tree, we can see that our stock prices are going up in the increments of plus 10, or it goes down by the increments of minus 10. And we have time 0, time 1, and we have 3 time steps in total. So in this model, you can think about how to price the financial derivative. So you need to start from the last time step and consider that we have the strike. This is a call option with strike price 100. So you need to first write down these payoff values, and then you need to go backward to calculate these values over here. And notice that the risk neutral probability, what's the risk neutral probability in this case? We can notice that the risk-free rate is given equal to 0 in this case. So that's going to be your P tilde is going to be equal to, again, just the current price is 100. For example, for this point, if I calculate the risk neutral probability P tilde and 1 minus P tilde here, that's going to be 120 minus 110 divided by 120 minus 30 minus 110, which is 1/2. So actually for this tree that we created, all the risk neutral probabilities are equal to 1/2. So that means you can just take these conditional expectations, 30 times 1/2 plus 10 times 1/2, and the risk-free rate is 0, so there is no need to discount, just multiplying with 1. So this is going to give you 20. So similarly, you can calculate each of these values and continue to go backwards all the way until you get to time 0. So that the time 0 value is going to be the no arbitrage price for this call option.